Okay, with the next couple of questions, we're going to look at how inequality can be used in real life situations. For example, question 9a, Adam is expecting more than 30 people to attend the party. So, how do we represent this using inequalities? So, we can represent the number of people with P, the letter P, and we know that the number of people has to be greater than 30. So, we can represent that with the following inequality. Question 9b, you have to be at least 21 to hire a car from our company. How would this be represented using inequalities? Well, we can use A as your age, and you have to be greater than 21 or equal, because it says at least 21. So you have to be 21 or over, so you have to be equal to 21 or greater. So we represent that example with the following inequality. So A is equal to or greater than 21. I suppose we could have also said A has to be greater than 20. So with this example here, when I'm saying A has to be greater than 20, you can't be 20 years old and hire the car. You have to be over 20, so the youngest you could be is 21. And here we're saying you have to be 21 or over. 21 years or over. So question 9c. So Mariam's monthly mobile phone contract is £10 a month. She can make unlimited video calls, but calls to Turkey will cost £2 a minute, or £2 per minute. So this £10 a month means that regardless of whether she makes a phone call or not, she'll have to pay £10 every month. And then she can call any of her friends or family in the United Kingdom. It's for free, that doesn't matter. But calls to Turkey will cost her £2 a month because it's a foreign country. So Mariam, being a sensible person, has set herself a budget. Mariam has an allowance of £30 a month. That means she will not spend more than £30 a month for her mobile phone calls. So the question is, how many minutes of calls to Turkey can she afford each month? So how many minutes can she afford to call Turkey each month using her £30 budget or allowance of £30? So the £10 is fixed. Whether she uses the phone or not, she will have to pay that £10. And then every minute, so we can represent the number of minutes she's calling with the letter M. So we'll have to add £2 for every minute, so 2 times M. So for example, if she was to use it for, if she was to call Turkey for 2 minutes, 2 times 2 will be 4. So it'll be £4 for those 2 minutes. And this has to be, so 10 plus 2M has to be less than or equal to 30. But that's her budget. So if we solve this, we can find out how many minutes she can afford to call Turkey. So the first thing, so we're going to find out what M is on its own. So to do that, we can take away 10 from both sides. So on the left hand side, 10 take away 10 cancels out, leaving us with just 2M. And on the right hand side, 30 take away 10 is 20. Now to get the M on its own, we have to go to the times 2 on the left hand side. So we divide both sides by 2. So on the left hand side, the times 2 and the divide 2 cancels out, leaving us just M. On the right hand side, 20 divided by 2 is 10. So M has to be equal to or less than 10. So she can make up to 10 minutes. This is what this means. She can afford to make up to 10 minutes of phone calls to Turkey each month to stay within the budget of £30. So she can make 10 minutes of calls or less. She's not allowed to make more than 10 minutes of calls. Question 9D. Danielle gets in a cab. it will cost him £2 plus 20p per mile driven. So £0.2 here is 20p. Daniel has an allowance of £10 per ride. How many miles can the cab ride be? So how many miles can you ride to stay within the £10? So the £2, doesn't matter how far he goes, he'll have to pay that £2. Even if he goes 1 mile, 10 miles, whatever, it's a fixed cost. So the expression can be, or the inequality can be started off with writing the 2 first. Then it's an additional 0.2 pounds or 20 pence per mile. So it will use X to represent a mile, the number of miles. And this has to be equal to or less than 10. So the first thing, so we want to find out what X is. What's the maximum number of miles he can go for a cab ride? So you've got to make sure you understand how we got this expression, or this inequality, sorry. The 2 is the fixed cost, it's the £2. No matter how far he rides, it's going to cost £2. And then it's 0.2 pounds per mile driven. So that's how we got the 0.2x. Okay, so the x represents the number of miles, and we know that's 20p per mile, so 0.2x, 0.2 times x. So we want to get the number of miles, which is x, and we want to get that by itself. To do that, we have to get rid of this 2 first. So to get rid of the 2, we take away 2 from both sides. So on the left hand side, this 2 and this minus 2 cancels out, leaving us just 0.2x. And on the right hand side, 10 take away 2 is 8. Now to get the x on its own, we have to get rid of the times 0.2. So we divide both sides by 0.2. So x would be less than or equal to 8 over 0.2. So this is a slight problem. We cannot have 0.2 as the denominator. So I've just moved all the writing over to the right, otherwise I can't fit it in. So the problem is here, we've got 0.2 as the denominator. We can't really have that, it makes it hard to solve. So what we'll do is we'll times the top and the bottom by 10, and that should help us. So x should be equal to or less than, so if we do 8 times 10 we'll get 80, and 0.2 times 10 is 2. Now you can see on the right hand side, 80 over 2 is just 40. So x is equal to or less than 40. So that means, so this is our answer. So that means Daniel can go up to 40 miles to be within the £10 allowance, within the £10 budget. If he goes more than 40 miles, then he'll go over his £10 budget. So this is how we use inequality in real life. So we use this expression, this inequality, to solve this answer here. So I'd like you now to try question 10 by yourself. If you've done solving equations, the playlist on solving equations, then question 10 should be relatively easy. So I'll make it a little bit bigger so you can see. So you've got 4 questions there. We've got another, there's 6 questions there, and there's 6 questions here. So altogether 12 questions. So solve the following inequalities and illustrate the solutions on number lines.